Hello everyone, welcome to another video, another celestial tour. There are many global issues Earth is facing, like poverty, hunger, and there are natural global issues like climate change, air pollution, water pollution, land pollution. Pollution harms our planet a lot, and one of the main contributors to land pollution is mining. Mining valuable elements causes habitat destruction, deforestation, erosion, and the negative change in soil. Because of habitat destruction, our planet is threatened, ecosystems are threatened, living beings are threatened, and in fact, they're dying. But what if there was a way to avoid all these? What if we started the industry of space mining? Although it is a very hard process with mining planetary bodies like the moon and especially asteroids, no one would get harmed. The planet Earth would have an eco-friendly future. In this video, I will talk about what we would face if we went to mine the moon or the asteroids, and what resources we can possibly mine on these planetary bodies. So without further ado, let's jump right into the video. First of all, let's talk about lunar mining. Now, you might be questioning, what is special about mining the moon? Isn't it just an object with some igneous rocks on it? As you know, a few years ago, it was confirmed that water is found on the moon. Mining water on the moon can not only develop life and agriculture in space, but it can also be used for the conversion of water into rocket fuel. The isotope helium-3 is found on the moon, and it can be a great resource for the nuclear electricity sector on Earth. Now, if we talk about mining valuable metals for manufacturing, the moon contains what we call REMs, rare earth metals, which are composed of the 15 lanthanides, scandium, and yttrium. Rare earth metals are very abundant in electronic devices we use today, like cell phones, computers, and medical equipment too. And unfortunately, the mining of REMs on Earth causes so many environmental problems. Technically, the cell phones and computers we use aren't very eco-friendly. But once we start mining on the moon and invest in REMs there, everything will change for the good. But how will we do this? Again, this will definitely be a hard process, but there are many ideas of what a lunar mining colony would look like. Manufacturing REMs on the moon can be done by using 3D printers, and there can be robot miners sent to the moon. And when it comes to the other substances like helium-3 and water, helium-3 can be captured in storage containers, and water can make human presence long in the moon. Now, we always talk about how living beings wouldn't be harmed on Earth, since there aren't any living beings on the moon. But how will the moon itself be affected? How can the changes in the moon's mass affect the tidal waves on Earth, for example? The moon has a mass of 73 quadrillion tons. If you remove the 1 metric ton from the moon each day, it would take 220 million years for the moon to lose 1% of its mass. And that wouldn't affect either the lunar orbit or the gravitational pull that causes tidal waves on Earth. However, the moon in human cultures and its visual impact on Earth can possibly change. According to the 1967 Outer Space Treaty, there will be a video about that, no nation can claim ownership of the moon, but actually there can be private ownerships for mining. So we've talked about what we can mine on the moon. Now let's talk about asteroid mining. Although asteroids might seem like a large boring rock floating in space, the types of asteroids can vary. When it comes to asteroid sizes, some can be very small with a diameter less than 10 meters, with a large asteroid Vesta, for example, with a diameter of 530 kilometers. When it comes to their composition, asteroids are divided into 3 classes. There are the C-type asteroids, which are the most common asteroids made out of clay and silicate rocks. 75% of the asteroids fit in this category. The S-type asteroids, which are made out of silicate and nickel iron, they're stony, and about 17% of the asteroids are in this category. And the M-type asteroids, which are also made out of iron nickel, but they tend to be metallic. A rare amount of asteroids are in this category. Now, for valuable elements like nickel and iron, S-type or M-type asteroids are the ideal asteroids that can be mined, especially M-type asteroids. An example of an M-type asteroid currently NASA is planning to observe is the asteroid 16 Psyche. This metal-rich asteroid is the heaviest known M-type asteroid, made of metallic minerals like nickel, iron, and even gold. In fact, even platinum is found on 16 Psyche. The presence of gold and platinum in this asteroid most likely is the reason why 16 Psyche is very valuable. With all the valuable elements combined, this asteroid's worth is about 10 quintillion US dollars. That's bigger than the worth of the global economy on Earth, which is 84.5 trillion US dollars. NASA is planning to check out 16 Psyche while exploring the origin of planetary cores, because it is said that 16 Psyche might have actually been an exposed iron, nickel, and gold core of a protoplanet. Mining iron, nickel, and gold out of this asteroid can improve the global economy, with its value can be used in pretty much anything from concrete to mobile phones, and simply 16 Psyche can supply our industrial needs of iron and nickel for several million years, and this can happen without polluting the Earth. Now, we found the ideal asteroid for mining, including many valuable elements that can help us with many industries. But how can you mine an asteroid, whether it is big or small, and extract all the valuable materials from it? First of all, the problem is that asteroids are very far away from us, even the near-Earth asteroids. A lot of fuel would be needed for the rocket that carries all the mining materials, and that will cost a lot of money. To reduce the cost of that, what can we do? There are two answers for this. What if we bring the asteroid to Earth? NASA's Asteroid Redirect Mission, aka ARM, was exactly that. The goal of the mission was bringing a 4-meter boulder from a near-Earth asteroid to cislunar space between the orbits of Earth and the Moon. That will cause the boulder to have an orbit influenced by the gravitational pull of the Moon. The other answer is that we can use machinery that is solar-powered, that would replace fuel, causing less mass. Speaking of less mass, all the equipment should be lightweight for everything to be transported to the asteroid. The mining process will be similar to the process on Earth. The most likely approach would be to drill into veins of particulate materials and scrape needed material off the asteroid. Now, this might be a mad mission, but some experts say that the robotic equipment should be used to limit the amount of personnel in the mining mission. This would reduce the amount of supplies, like food. In my opinion, I think this would be the best, because a human mining a space object can be risky, especially if the asteroid is smaller in size, because the lesser the mass, the lower the gravity. The valuable materials will be removed through scraping or strip mining and will float off the asteroid. Since the metals would fly off, a large canopy can be used to catch all of them. And basically that's some steps of how to mine an asteroid. There are a lot of things needed for the mining of an asteroid, but to not make the video lengthier, these are basically the highlighted ways of how an asteroid can be mined. In addition, you can check out Kurzgesagt's video about asteroid mining. The topic is well explained in the video, so you can watch it. In conclusion, mining can be very harmful to living organisms on Earth, but when we mine on the Moon or on the asteroids, things can be much better. The Moon provides REMs that are used in electronic devices. Asteroids, specifically M-type asteroids, provide a good amount of iron and nickel that can supply the needs for industries like manufacturing for millions of years. Will this be possible? If people work hard on performing all the equipment, just like how they did on previous space exploration milestones like the Apollo 11 moon landings, anything can be possible. But of course, we should be aware of how mining in space can be a hard process. Mining on the Moon might be easier since we're more familiar with that, and there are missions planned for that. Like the Artemis mission will send humans with their lunar bases, and they possibly will mine all the needed materials on the Moon. But asteroid mining might be a harder process, like bringing the asteroid in between the orbits of Earth and Moon, then doing the mining process. That would most likely be a hard thing to do, but again, we have hit many milestones in space exploration in the past, and space mining will eventually be another milestone, so only time will tell. Anyways, I hope you liked that video and learned about the idea of what space mining would seem like. Thank you for watching, and stay astronomical.